Hello everyone, welcome to the video. Today we will talk about air refrigeration system of type 3. Before discussing further, I just came across a few people who are scared of RAC and have dropped their weapons. I would just want to say a few lines from a poetry, that is, मन के जीते जीत है, मन के हारे हार, हार गए जो बिन लड़े, इन पर है धिक्कार. So we need to avoid that धिक्कार. We need to fight for it. There is no rocket science. In every video we'll complete the poetry one by one. This was the first line. So now let's get to the topic. So as discussed earlier, the ambient air enters the conduits. Here the ramming effect takes place. It goes to the main compressor 1. From the main compressor it undergoes 2' to 3'. Then it flows through the heat exchanger 1. Now let's talk through the processes directly to get a better understanding. 1 to 2' ramming effect, 2 to 3' isentropic compression in the main compressor, that should be 2' to 3'. Then 3' to 4 cooling of the first stage compressed air into the heat exchanger 1. So here the first stage compressed air comes from MC1, then it passes through the heat exchanger 1. Cooling of the first staged compressed air, that means cooling of this red arrowed tube by this rammed air. So the heat is rejected from the tube to the shell. It is cooled. Then from 4 to 5 isentropic compression in this secondary compressor. 5' to 6 cooling of the secondary stage. So 5' to 6 in this process, cooling of the secondary stage compressed air, the air coming in this tube, cooling of this air in this tube using this rammed air in the outer shell in heat exchanger 2. 6 to 7' is an isentropic expansion process in the cooling turbine, and 7' to 8 is a heating of cold air. Now you would say that what does heating of cold air mean? So for example, if in the cabin the temperature of the cabin set is somewhere 22 degrees Celsius, or datum or the reference temperature of the cabin is 22 degrees Celsius, and the temperature of air coming after expansion is some 10 degrees Celsius, then the difference between this air and the cabin air is a huge difference of 12 degrees Celsius. This huge difference can lead to condensation, overcooling. Overcooling is very uncomfortable for the passengers. So this air is heated to a temperature which is near to the cabin temperature to maintain the humidity, to maintain the chillness, and to maintain a proper climate. Would not say like a proper atmosphere nahi, but to maintain a proper air into the system or into the airplane. So now talking about the processes, 1 to 2 ramming effect, 1 to 2' ramming effect, 2' to 3' isentropic compression in the main compressor, 3' to 4. One thing, we can see that 3' to 4 is the cooling, the reduction in temperature into the heat exchanger, but we can observe that the whole process is undergoing on the same pressure line. So it is an assumption that in the heat exchanger there is no pressure loss into the system. We can see that from 3' to 4' the heat is lost to the rammed air. The heat from the first stage compressed air is lost to the rammed air. It rejects its heat to the rammed air with negligible loss of pressure. So we can again see that from 4 to 5' it undergoes secondary compression, and from 5' to 6' again it is an isobaric process. So in the heat exchanger we assume that there is no loss of pressure and they are totally isobaric in nature. Now talking about the calculation part, we can see that the flow rate of air is 210 into Q is in TR divided by Cp into T8 minus T7'. Now देखने जाए तो we know that in VCRS we used to look for the refrigeration effect. Refrigeration effect was the amount of heat extracted from the refrigerated space. That was our refrigeration effect, and we used to take the temperature difference between that two terminals. But in a air refrigeration system, we don't follow totally that analogy. In air refrigeration system, we just look for these 2 points. So either this is the place wherein after where the air is released into the cabin, इधर से ही air cabin में आता है from 7 dash to 8. These are the 2 points after which air comes into the cabin. So we don't take the difference between the initial and final points like we did in VCRS. Either we just see that between point 7 dash and 8, here is the main cooling action taking place. You get it? Here is the cooling action taking place. Nowhere is the heat accepted or rejected. We see that where is the cooling action taking place. Here is the cooling action taking place, and that cold air is released into the system. So here is the point, or here are the 2 terminals wherein we expect or we consider the cooling effect, or the cooling not the cooling effect but the cooling action. So hence we do T8 minus T7 dash, W net in P equals MA into Cp into T3 dash minus T2 dash. Here we could see in the first compressor. Now I missed the point. Here is a shaft. So you could say that why is only the compression effect of the first compression taken into consideration and not these 2? So why only like in VCRS, if there were 2 compressors, then we do work done equals work in first compressor plus work in the second compressor. But in this case we can see that work net is just equal to work done in the primary or the main compressor. The reason being that here is the shaft connected between the air and between the cooling turbine and the secondary compressor. So this compressor is powered to an auxiliary heat source, that is the combustion chamber. We need to provide fuel to the combustion, which rotates the gas turbine, which rotates this shaft, and which operates this compressor. But for the secondary compressor, we have a shaft connected to it, wherein the air flowing with its natural kinetic energy passes through the turbine. And we know that turbine doesn't require work, it moreover produces work, because an expansion process generally produces work, the work being negligible. We don't consider that, but always a turbine doesn't require work, it produces work. So as the air passes through it, it has its natural kinetic energy as it is pressurized, so it rotates the turbine, it exits by expanding. But as it rotates the turbine, that turbine is connected to this shaft. As it rotates the turbine, it rotates the shaft, and this shaft provides power to the secondary compressor. So the power provided to the secondary compressor is totally bootstrapped. Here the word means bootstrap. Bootstrap means जुगाड़ से खुद का पैसा खुद यूज किया. Bootstrap means if any business starts with his own money and not by using his investment, by asking for any investments, then it means bootstrap. मतलब खुद का ही एनर्जी खुद यूज किया. He isn't asking for any extra power. He is using his own energy. Similarly, by a startup analogy, if someone is bootstrap, means he is using his own funds. He is not asking anyone for any funds. He is just bootstrap. He is using his own funds to empower his own business. Similarly here, the system is using its own energy. This energy was obviously going to be wasted. So the cooling turbine rotates, it rotates the shaft. Hence it powers this secondary compressor. It rotates the shaft of the compressor. A compressor is simply an opposite of a turbine. A turbine expands. As it expands, and compressor compresses. It goes from here to here. So it rotates the shaft and it rotates the fan in the opposite direction. As we know, it is just this minor difference. So as it expands, this shaft rotates and this compresses. Simple. Hence, there is no external or auxiliary power required for the secondary compressor. Don't think much. It is the only reason that it doesn't require any auxiliary power, so we don't consider it here. So therefore, the COP equals 210 into Q by MA into Cp, T3 dash minus T2 dash. Here there should be 60 for mass in kilogram per second. Try to keep all values in kilogram per second. or the kilojoule per second to get kilojoule per second equals kilowatt, and to get the values or the units better. So this was the COP, 210 into Q divided by 60 into MA into CP divided by this compressor zone, this 2 dash to 3 dash. This is the temperature difference of the compressor. So again I repeat, the work done is always considered of the primary compressor, that is the main compressor. We don't consider the secondary compressor as it is not auxiliary powered. It is a bootstrapped system, that is, it is harnessing its wasted energy. There is no extra work given. Hence we only consider work done in compressor 1. Thank you very much.